All right, we'll get going here in 1 second. And all right, Brandy, thank you for that. James, you can hear me? Good deal. All right, a couple settings done here. We will get going. Everything in the proper position, and Brandy, that should do it for you there. All right. And okay, so where we left off was a video. So the video was, and I have quite a bit of information in this PowerPoint presentation. So I'm going to show you this first one here, and then we're going to go into the lab. We'll discuss irrigation systems here a little more. We have it throughout the week, irrigation systems, and we'll be working through the details that we covered on the first part of the presentation. All right, so design a sprinkler system. So how to measure your yard easily and accurately with your sprinkler irrigation system. As it says here, one size does not fit all. So with that said, it is a science. I don't want to say so much as science, but it is definitely a profession in setting these irrigation systems up. Number one, setting it up, period, so it works. Number two, for efficiency. We talked about the different types of irrigation, the impact, pop-up heads, drip lines, soaker, we didn't mention soaker hoses, but that's another one. Different types of emitters within that. So we'll get more into that specifics, but what I'm saying is there's a whole technology about how to get it set up properly so it's efficient. A lot of places in California, I don't want to say a lot, some are going to the artificial turf. There's all kinds of discussion on that. You can ask me on that, and I would have a very hard time about going to artificial turf or grass. But I'm old school. You know, maybe the younger generation that likes a green lawn area, maybe they, maybe you would want to go with that. The people that are a little more hardcore. And I don't think I'm hardcore, but ecologically, conservation of water. I mean, the lawn does take a lot of water. I admit it. It takes a lot of maintenance, the aeration, feeding, weeding, and just, on and on. Some of those things I enjoy doing. So I'm maybe not the best person to ask about artificial turf. We have to be taking these things into consideration as we move forward and our environment continues to change. So let me go ahead and show you this video on the irrigation system and how that is designed. To figure out what the heck I'm doing here. It's Monday. Give me a break here. All right.
This course is about designing a residential irrigation system. We'll begin by measuring the job site and preparing a plot plan and determining the available water supply. From there, we will discuss proper sprinkler selection and layout, dividing the system into zones, sizing and laying out pipe, and finally, completing the design to create a finalized plan. The design process begins with a visit to the job site. In order to make the most of your visit, you'll need a 250-foot tape measure, information about water pressure in the city water main at that location, a pressure gauge, and a clipboard with graph paper and a pencil to help you record your observations quickly and efficiently. It's important to measure the property carefully because inaccurate measurements can lead to problems with pressure and coverage that could require expensive repairs after the installation. We'll start by getting accurate measurements of distances on a property. The easiest way to do this is to lay down your 250-foot measuring tape along the curb of the property. Use this measurement to choose a scale on your graph paper and draw the edge of the property at the bottom. Walking behind the tape measure and looking straight back into the property, you can line up the edges of structures and landscape elements with the marks on the tape measure. On the graph paper, mark the location of the edges of all major elements of architectural and landscape design, including the location of the house, driveway, sidewalks, pools, decks, or patios, and significant landscape elements like trees, shrubs, landscape beds, and any borders between different kinds of plantings. Once you have measured the property from the curb, repeat the process with the measuring tape stretched along the side of the property at a right angle to the curb. You'll now have 2 coordinates for everything on the property, and you will be able to easily draw the property to scale on your paper as you go. For houses with complex back or side yards, you might need to repeat the process along the back edge of the property and on the other side, but 2 passes are sufficient for most properties. In addition to properly measuring the property, there are several other important pieces of information to note that will affect your design. Identify the orientation of the house with an arrow pointing north, and note which parts of the property are full sun, part shade, or full shade. Also note any plant material covered by overhangs that will not receive rainfall. Having drawn in the borders between plantings, note what is planted where, especially for plants with significantly different water requirements. Indicate the direction and grade of any slopes on the property, and the direction and speed of the prevailing wind. Additionally, know your local codes and identify the place where you will tap into the water supply, and find a location near an outlet for the controller. Finally, confirm the soil type before leaving the property. You can perform a squeeze test to determine whether the soil is predominantly clay, loam, sand, or some mixture of the 3. When a moist ball of soil is squeezed, clay soil will retain its shape when poked, loamy soil will break apart when poked, and sandy soil will completely fall apart before forming into a ball. A plan drawn to scale with complete and proper site information is essential for completing a design that will enable easy installation of an efficient, easy-to-maintain irrigation system. The primary limitation on the design of an irrigation system is the maximum allowable flow rate. This determines how many sprinklers can operate at a single time, and will affect how the sprinklers are grouped into zones and how long those zones need to run. There are 3 tests to determine the maximum flow rate available for an irrigation system. Number 1. The maximum flow rate with a pressure loss at the meter less than 10% of the city's main static pressure. Number 2. 75% of the meter's maximum allowable flow rate. And number 3. The maximum flow rate with a velocity under 7 feet per second in the service line for copper or steel service lines. The maximum allowable flow rate will be the lowest of these 3 numbers. Let's run through a calculation for a sample system. For this calculation, you'll need 3 pieces of information. Number 1, the minimum static water pressure of the city main. This information can be obtained from the water purveyor. You can verify on-site at a spigot with a pressure gauge threaded onto a hose adapter. Number 2, you'll need the water meter size, which is usually stamped onto the top of the meter. And number 3, the size of the service line. Let's consider an example where the static water pressure is 75 psi with a 3/4 inch water meter and a 3/4 inch service line. What's our maximum allowable flow rate? First test, the maximum flow rate with a pressure loss less than 10% of the city main static pressure. Since our static water pressure is 75 psi, the maximum pressure loss is 7.5 psi. Consulting the pressure loss through water meters chart, we see that the maximum flow rate under the 7.5 psi pressure loss is 20 GPM with a pressure loss of 6.5 psi. Second test, 75% of the meter's maximum flow rate. Returning to our chart, we see that for a 3/4 inch meter, the highest pressure loss recorded is 15 psi at 30 gallons per minute. This means that 30 gallons per minute is the maximum flow rate for this meter. 75% of 30 gallons per minute is 22.5 gallons per minute. And the third test. The maximum flow rate with a velocity under 7 feet per second in the service line, or steel and copper service lines. We've got a 3/4 inch copper service line, so let's have a look at the chart for type K copper tube. We can see that for 3/4 inch pipe, 9 gallons per minute is the maximum flow rate, with a velocity under 7 feet per second, clocking in at 6.61 feet per second. The lowest flow rate that passes all three tests is 9 gallons per minute, so we'll use this one to design the system. With all of the site information in hand, you are ready to divide up the plan into separate watering zones called hydrozones, based on the watering needs of the plant material. There are 3 variables to consider: sunlight and weather exposure, area size and shape, and the type of plant material. First, divide areas that have significantly different sunlight and weather exposure. If a treeless front lawn is on the south side of a house, it will require significantly more water than a shady backyard on the north side. To allow the system to adjust for the different water needs, these areas need to be in separate hydrozones. Similarly, if a landscape bed is wholly covered by an awning or an overhang, it should be separated into a distinct hydrozone from landscape beds that receive regular rain. Next, divide up areas according to their size and shape. A large turf area will require different kinds of sprinklers than, for instance, a narrow strip of turf between a sidewalk and the street. Divide these into distinct hydrozones. Finally, divide up areas with different kinds of plant material. High water usage plants like turf should be on different hydrozones than low water usage plants like ground cover or more sparsely planted shrubs. A point source drip system can provide different quantities of water to plants on a single zone, but most irrigation methods distribute water evenly over an entire watering area. Areas with different water requirements should be in separate hydrozones. This prevents a scenario where some plants are underwatered while others are overwatered. Let's take a look at an example. Suppose this is the plot plan of the property we are designing a sprinkler system for. We'll want to start by dividing the front of the house, which has full sun, from the back and side, which is part full shade. Additionally, the side yards and the front strip are quite narrow, so we'll break them off into separate sections as well. The landscape plantings constitute another area, and in this plan, there aren't any plantings covered by overhangs. Once the plan is divided into hydrozones, we're ready to select sprinkler heads. There are 5 main types: rotors, fixed sprays, spray heads with rotary nozzles, specialty pattern sprays and bubblers, and micro or drip irrigation. Each of these sprinkler heads have advantages and disadvantages, and to understand the differences between them, let's quickly define a few terms. Radius. The radius of a sprinkler head tells you how far it sprays water. The longer the radius, the bigger the circle the sprinkler head covers. Flow rate. The flow rate is measured in gallons per minute, which is critical for determining how many sprinkler heads can run on a single zone. Precipitation rate. The precipitation rate is measured in inches per hour, and it tells you how many inches of water the sprinkler head will put onto the ground in an hour. You'll use this information to calculate run times for the controller. All of the sprinklers on a particular zone must have the same precipitation rate to water evenly. On a typical performance chart, the precipitation rate is given both for square spacing and triangle spacing. This refers to the way that the sprinklers are laid out. Square spacing refers to a grid of squares, with sprinkler heads at each corner. Triangular spacing refers to a grid of equilateral triangles, with sprinkler heads at each corner. Triangular spacing is more efficient and has higher precipitation rates. Operating range. Each sprinkler type works best within a limited range of operating pressures. While the pressure of an irrigation system is in many ways determined by the location, you can add pressure to a system with a booster pump and regulate pressure with pressure regulating valves and sprinkler heads. Once the design is complete, we will calculate the operating pressure at the last head to ensure that it is operating within the recommended range. Now let's take a quick look at each type of sprinkler.
All right. I stopped the video there. It's just about a half an hour long. So we're going to continue this tomorrow on this. Hopefully that was a lot of, I know it's a lot of information in one short time, but again, these are available for you to review. If you are thinking about doing a lawn, this will give you some information. You, of course, you won't have to go through all the calculations. I'm not going to ask for all the flow rate and the gallons per minute calculations on this, but if you're thinking about putting a sprinkler system in, this will give you some good information, a good way to start. For our class, this is going to give you some good terminology and get you familiar with sprinkler systems and the terms used them within the industry. All right, so for right now, I want to go to, let me stop sharing this. And we'll continue this.
Rotors come in different sizes, different radius.
He wants to continue now, but we're going to continue tomorrow. And right now, I want to take a look at the assignments for this week. And then we'll go into lab. All right, this will be a recap. I have that on video as well, and that's only 4 minutes, and then we'll go into lab after that. And as always, make sure you post any questions or write down any questions and email them to me, or whatever format you want to use. But you know, for the benefit of the class, don't hesitate to post questions in the chat area, and we'll talk about them afterwards. The week ahead of us, what is the store as far as this? All right, this will be a recap for the week ahead of us. What is store as far as assignments? This week we'll have projects as usual, but we're also introducing the final project in week number 3. All right, the first thing we want to take a look at is we have 3 PowerPoint presentations. There will be a 4th. I haven't completed number 10 yet, so that's right at the top up there. And we also have attachments for the final project, which includes the scope of the rotundra. All right, so if I get the right one up there, that would help, unless I put the wrong link in here. Let me find out. Packet 4. Of course, there's no video showing up for packet 4. That's interesting. All right. Hold on one second. Let me see what's going on with that, because I did post them in there. All right. So we will go over this manually. The old-fashioned way. All right, so the first assignment on packet 4, we're looking at, well, that's even more interesting. Okay, no, we're good. Assignment 1 is design an irrigation plan for your front yard project. Submit on a D sheet, PDF, and DWG. Examples, I posted a couple examples up here. Attached include this information here, and use the PowerPoint. I think it was slide number 2 as an example. Also, I posted an example up here from a previous student that did some work as well. So that's number one. And then number two, make a block for each plant of your front yard. So each plant that you're going to either use or keep in place, make a block for it. And then you'll submit that, see Chapter 5, for example, of blocks, and submit that in a table format using the notations here. Plant picture, plant block, plant name, shade or sun, size, quantity, and total cost. We've made a plant table already, so you have a start on this as well. So you just need to add these categories into it to complete assignment number 2 along with the blocks and pictures. On that, here I have 3 different types of trees, 2 different types of ground cover, etc. So I'm going to revise that and go back to my announcement statement. That had a misspelling in it. I'll fix that as well and revise that and just say a minimum of 1 of each kind. So if you're replacing something or if you have something that you're going to keep, such as Larry brought up about the grass, just put that you're not going to add any new grass in there. You're going to keep existing St. Augustine grass, whatever it is. Or if you're pulling that grass out and going to put it in, new grass in, and call out what you're putting in, etc. on that. So I'll change that each one to 1. Well, you know what? That was for your selection. Let's see. Okay, yep, I'll change that to 1, and we're good. And then make sure you're prepping for the midterm. Again, we'll go over that on Thursday, but we're going to just basically cover the same format or have the same format that we had in the pop quiz. And so for Thursday and Wednesday and Thursday, there is no additional work. So don't forget, besides these assignments, you want to be working on that final project one. And I sent you out some dates on that, some soft dates as well. And I think that was an announcement. So I go back to announcements. And maybe that was an email. No, right here, the soft dates on these to kind of keep you guys on track. So by today, you have the site plan with a vicinity map and site analysis in place. All right. So that should be all set up on the D sheet. Now, if you're not 100% done on that, don't panic. Go ahead and get it set up on D sheet, but you can keep working on it. All right. But you can see how these sheets need to be accomplished. So by the 14th, you're completed. And then by the 16th, which is the due date, December 16th, be able to submit the final project. So make sure you're still working on that. But for Wednesday and Thursday of this week, there is no additional assignments other than what we just talked about under lessons and packet number 4 for Monday and Tuesday. All right, let me come back over to the chat area here and see if anyone. Larry says, can I put the annuals in a big flower pot and put the pot on my porch? Yes, you may, Larry. That's part of landscaping. Absolutely. That is part of it. Don't forget one thing, Larry. Odd numbers are best. So if you have one pot, you also, if it's a one huge display pot, maybe that's a focal point. Don't forget about fill and spill. But if it's not a huge pot, you're just having one, maybe it just was some annuals in there, you might want to add a couple smaller pots to have that 3. Remember, 3 odd numbers are best for eye appeal. So absolutely, Larry, that's part of landscaping. Absolutely. Any other questions on that or anything else that we've talked about? Yes, odd numbers. Yes, 3s, 5s, 7s, 9s. James McGinn says, was the Rotunda Garden supposed to have a vicinity map on the D sheet? Let me go back to, I don't know where that was at. Are you talking about last week's assignments? I'm not sure which one you're talking about. You're going so fast here. I'm going back to last week's assignments. Assignment 1 said the final project Rotunda Garden, snip the TCC. Sample attached, include adjacent sidewalks, outline all features except rotunda, submit with map turned on, scale drawing. So nothing about in that one as far as a vicinity map. Let's see what else you put on here. So now we're talking about the front yard project. You're asking about the front. So if you look at assignment 2, which is the front yard project, assignment 2 was the amenities. And then assignment 3, if we look at that, that was the front yard project as well. And there's all the details on that. And I'm scanning through here, and right here it says vicinity map, right here. All right, so did that answer that, James? I wasn't too sure where you were going with that. Okay, cool. You said yes. I don't know if that yes was from previous or from what I just said.
Yeah, that answers it.
Oh, hold on, James. Let me turn up my speaker. Okay, go ahead, James.
Yeah, thought you said that the Rotunda Garden was supposed to have a vicinity on the instructions you were just showing. I just wanted to double check.
Well, it will eventually, but if you're talking about assignments, no, it doesn't call it for on the assignment 1.
Okay.
Cool. But it will need a vicinity map for the final submission, final project submission. All right. Anything? Yeah, Zach, go ahead. Oh, Zach left. I thought he had his hand up. All right. Anything else?
Mr. Taft.
Yes, sir.
So on the final project, there is a vicinity map on there somewhere, right?
Yes, sir. Correct.
On one of the sheets.
That will be on the site plan. Let's see what.
Yeah. So there's 6 sheets that we turn in for the final project altogether.
Right.
Okay. And just going over this so I'm getting straight in my head. Cover sheet and on down. 6 sheets on one PDF that we send it.
Correct.
Okay. Do we send the drawings with them?
DWG, yes, always DWG and PDF. Yes.
Okay, so we'll have 6 drawing files and 1 PDF file with all 6.
No.
No?
Do all your drawing in one DWG file.
Okay.
I think I sent out a video on that. So like we have separate projects going right now. So let's call the Rotunda one project and the front yard another project. So the Rotunda, you're going to do all your drawings that are associated with that, all 6 sheets that are associated with that in model space in one file. The front yard, you're going to do all the front yard project. You should do that in one DWG in one file.
Okay.
All right. So
I think so.
I think where the confusion's coming in is people are going, oh, he's asking on the Rotunda this week, he's asking for one D sheet. And here I have 6 D sheets set up in my file, right? So that's where you can do a save as and delete the new file. It can be Rotunda project number 2. You can delete the D sheets you don't need and just send in that one D sheet. So the best advice I can give you is do everything in one DWG file and then figure it out from there.
Okay. I sure wish we could be in class.
Yeah, I know. I do too, Larry.
You could show me. I could figure it out. I could do it.
Well, that's why I made the videos. So
Yeah.
I made a video for that just recently on that very same subject.
Okay, I'll watch it.
Yeah, take a look at that. I sent it out. I think what it was called. Let's see. It was called. Oh, two different. Oh, it's the last one I made. Let me. I'll put the link in here in the chat. There's the link for. It's called two different projects with two different sheet size requirements. How to make one PDF with multiple sheets. So hopefully that will
Yeah.
help.
Okay, that's the one I had. I don't know. I think I got it straight now.
Okay.
We'll see.
All right. James
All right.
Lee, go
Thank you.
ahead.
Okay, so for our final project, we don't add the first part that we just did, the map and all the tracing. That's not going to be part of the 6, correct?
Yeah, well, yes, yes, it is. I mean, it's not going to be exactly that, but it's a
Yeah.
it's a base where you guys get started. That's why I say if you just keep that final or any project in one file, you can just build off it. You can manipulate it. You can add sheets. You can delete sheets. You can do everything from
Okay,
that.
yeah, that answered my question. I just wanted to make sure that that exact, I knew we'd build off of it, but I didn't, I was looking at it earlier. I'm like, yeah, there's nothing that exactly says that one. So I'm wondering if we transform it into something else later, or,
Okay. Yeah.
and you seem to answer that right there. You said we
Yeah.
build off of it. So
Right. Okay.
eventually it will, at the end product, it will look like something else.
Yeah. So let me go back to something. I lose it. Subscription. Where did I go? Oh, now here we go. So if you go back to announcements, here it gives you some information: cover sheet, 2-point perspective, and index. Site plan, a vicinity and with a vicinity map and site analysis. That will be all on one sheet. Landscape plan, we've covered that. All notes with plant legend. Irrigation plan, that's what we're talking about this week. Show the coverage and drainage. So all these, the announcement with the list of the 6 sheets gives you some information what should be on the sheet. Now, with that said, if you have questions as we get closer to the final project submission, you go like, hey, I'm not sure exactly on the detail sheet, for example. We're going to cover that. But the detail sheet, you see the planting of four detail planting. What does that look like? You know, if we didn't cover it or something, you know, give me some more information on that specific. But don't hesitate to ask any question about the 6 sheets. But this gives you a good base on the announcements. You know what you're working towards, and everything I give you as far as an assignment dealing with Rotunda will start laying a foundation for that.
Okay, so the assignment we just did, that we can just build off of that and make the site plan off of that, for example.
Yeah, like,
Okay.
yeah, exactly.
Okay. Thank you.
You're welcome.
I got another question.
Yes, sir, Larry, go right ahead.
Okay, and on the detail sheet, is that 8, 12, 16 different viewports on one D sheet?
We're gonna have 4 plantings. Yes. So 16. 4, 8, 12, 16. Yes.
Okay, so we build a D sheet with 16 different little viewports on it.
Yep.
Yeah. Okay, cool. Never done that. All right.
Very much the same way as the vicinity map. If you want to use that process, there's other ways to do it in CAD, but you can just measure it across and take, let's see, what would that be? 4 rows of 4. That would be your 16, right?
Yep.
You can just draw them out with a regular line work. Divide your sheet up, make 4 rows of 4 with regular line work, and then come back with viewports and just snap it right in each one.
All right. Interesting. Okay.
Yeah. All right. Anything else? All right, so you guys have a good 45 minutes if you haven't started working on your assignments and final project to get going. Tomorrow we will continue that video. If you want to look ahead on anything, there's plenty of information on irrigation, and we'll be talking about irrigation all week. All right, I will be here until 3:15. If you have any questions or problems, let me know. I'll be here. Thanks so much. And if I don't talk to you, have a great week. James Meek, did you still have a question? Your hand was still up. Just wasn't sure.
I didn't take it down, sorry.
All right, no problem. Just want to make sure I'm not missing you. All right, I will see you all tomorrow or talk to you in a few.
One more question.